Well, hello. In this video, we're going to answer the question, how do we solve right triangles using right triangle trigonometry? And you see, trigonometry is just the study of angles. So for right triangles, we can use SOHCAHTOA. And you might remember this from geometry. The SO is in reference to the sine of an angle is equal to the opposite side over the hypotenuse. The CA is the cosine of an angle is equal to the adjacent over the hypotenuse. And finally, the TOA, the tangent of an angle, is equal to the opposite over the adjacent. All right, so let's actually look at a basic 3, 4, 5 right triangle. And we're going to find the sine, cosine, and tangent of this angle right here. So again, if sine is the opposite over the hypotenuse, then the sine of theta would equal the opposite of the angle, so you go across, 3 over the hypotenuse, 5. So the sine of theta is 3/5. The cosine is the adjacent side over the hypotenuse, and that's adjacent is whichever side that's touching the angle that is not the hypotenuse. So the cosine of theta would equal 4 over 5. And then finally, the tangent, since it's the opposite over the adjacent, just for this angle, the opposite over adjacent would be 3 over 4. And again, these are all just the sine, cosine, and tangent of this angle. Our numbers would be different if we were looking at this angle. Okay, so what if I actually wanted to figure out what that angle was, right? We saw in the last example that sine of theta was 3/5. So what does theta equal? Well, in order to do this, you would have to use the inverse of sine. So that would be theta equals the inverse sine of 3/5. And this button is on almost every calculator. A quick note, your calculator must be in degrees, but once you solve this, you get theta is equal to about 36.87 degrees. See, and once we have this angle, we could use this to solve for that angle. And we should also notice that if we were to do the inverse cosine of 4 over 5, we would have gotten the exact same angle because, theta is theta. All right, let's keep going. The reciprocals, secant, cosecant, and cotangent. These are their abbreviations, SDC, CSC, and COT. And secant is the reciprocal of cosine, which means that it's equal to 1 over cosine. Cosecant is the reciprocal of sine, so this is 1 over sine. And you guessed it, cotangent is the reciprocal of tan, 1 over tan. So then we just got to remember, okay, since cosine is adjacent over hypotenuse, its reciprocal would be the hypotenuse over the adjacent. And sine was opposite over hypotenuse, so this would be hypotenuse over opposite. And instead of opposite over adjacent, we have adjacent over the opposite. So let's find the secant, cosecant, and tangent of theta, given that sine of theta is 15 over 17. All right, let's start by drawing the right triangle. We're given some right triangle. We can label any angle theta. We know that the sine of theta is 15 over 17. So the opposite of theta would be 15 over the hypotenuse, 17. All right, next I need to find this missing side using the Pythagorean theorem. And so let's assume we already did that and we found that this side was 8. All right, and before we move on, I noticed that I wrote tangent up here whenever I really wanted cotangent. All right, so let's find secant, cosecant, and cotangent of theta. All right, and let's remember that secant is the reciprocal of cosine. So whereas the cosine of theta would be 8 over 17, the secant of theta would be 17 over 8. See if you can find the other two. All right, so cosecant, you should have gotten 17 over 15, since that's the reciprocal of sine, which would be 15 over 17, and cotangent was 8 over 15. All right, here I'm given the angle, and I'm told to find x. So for this angle right here, I'm looking for the opposite side and I have the hypotenuse. So which ratio includes the opposite and the hypotenuse? Well, the easiest would be the sine. So we know that the sine of 40 degrees is equal to the opposite over the hypotenuse, 12. So solving for x would just be 12 times the sine of 40 degrees. Again, remember to put your calculator in degrees, which you can find under mode. So the length of x is 7.71 units, whatever units we're in. All right, let's try to do a challenging problem where we want to find just the length of this x right here. Go ahead and take a second to copy this triangle down because this is going to require quite a bit of work. All right, so the very first thing that I'm going to find is the length of this base of this first smaller triangle. So I have to think, which ratio do I want to use if I have the opposite and I'm looking for the adjacent to this 55? Well, opposite and adjacent is tangent. So let's just give this side some letter m. And the tangent of 55 degrees will equal the opposite, 14, over m. So moving some things in the equation around, we get m equals 14 over tan 55. So m equals 9.8. Right, the next side that I want to solve for is this hypotenuse of the larger triangle, and I've just given that a letter n. So in the larger triangle, I have this angle 30. I know its opposite side is 14, and I'm looking for the hypotenuse. So here, I'm going to use sine. The sine of 30 is equal to 14 over n. And then I can rearrange the equation in the same way to solve for n. And I see that n is equal to 28. Alright, so how am I going to use that this side is 28 and this is 14 to find the length of this x? Well, we can use Pythagorean theorem. We know that 14 squared plus 9.8 plus whatever that x is squared is equal to 28 squared. So I start by just getting this 9.8 plus x squared by itself by subtracting the 14 squared, and I get that 9.8 plus x squared is equal to 588. Take the square root of both sides, and we can reject the negative because this is a triangle. 9.8 plus x is equal to the square root of 588, which is about 24.25. Subtract 9.8 from each side, and we get that x is equal to 14.45. Alright, that's how we solve right triangles using trigonometry. Goodbye.